Okay, I start the class now because it's only 1 hour now. Okay, good afternoon for science 1, for science 3. How you are getting on at home? I hope everybody's fine, doing fine at home, stay healthy. Okay, and I never expect this CMCO the government called it back again, so all the schools shut down. But officially now, plus your schooling day is still on, until the last day, which is 18 December. So meaning that starting yesterday, 9th of November, right, until 18 December, basically you still need to attend classes, online classes, as all your teachers also supposed to teach using online or whatever platform, follow the timetable given, okay, the online timetable. So officially, so remember now, you are still attached to the school, until last day, which is 18th of December, okay? So your official holiday is only start on 19th of December, okay? From 19th December until next year, January, I think 19. When you're supposed to come back next year, you know or not? When are you supposed to come back next year? Chok Kerin, do you know? Chok
Yeah.
Next year, when you're supposed to come back to school?
I forget.
Don't know
Ah.
Darren, what about you? Next year, when are you supposed to come back to school?
I think
Darren?
around 20
Yes,
January.
20 January, the first day is 20 January, you officially come back to school. Okay, hopefully you all can come back to school for your starting your new year from 5. Okay, now I want to tell you all, next year your Form 5 physics syllabus, you have 7 chapters, which is very, very long. I mean, this year from 4-1, every chapter 1 to chapter 6, you have to study it well. Next year, no more time to cover the Form 4 chapters, understand? Form 5, you have extra 1 chapter, altogether 7 chapters next year, including the new chapter, quantum physics, which is a new chapter, very hard one. Okay? Okay, so listen to my advice, okay? So you stay home, all the time stay home, continue to study, okay? Of course, you need to sleep, to rest, okay? If possible, can avoid, you don't go any place or stay home, okay? Stay home. Try not to travel, because as long as you travel, you expose yourself to the virus, okay? Stay home now, okay? Right, okay. I want to finish up the last question of this paper. You all have this paper with you? This paper, the lesson 5, okay? Can you take out this paper, everybody? Lesson 5. And later on, we go on to this lesson, okay? Lesson 6, 7. Okay. Okay, let's start now. I share the paper with you, okay? If you cannot see, you let me know, because a few months I never use my Zoom already, Certain thing I've forgotten already. If a little bit slow or make mistake, don't laugh at me, okay? A few months I never use already. In fact, I didn't pay for a few months. I thought no need to use already. So only Sunday night only I renew my license only for this Zoom. Sunday night only I think cannot be avoided already, have to use, so I renew my license again. Okay, so there's a lot of things I need to catch up later because I still don't know, forgotten already how to use. Okay, come, let's look at the paper. Can you all see the screen or not? Can see the screen?
Yes.
Can see the paper?
Yes.
Can hear me? Okay,
Yes.
maybe certain class are different, so I want to finish up question 25. Can you look at question 25, everyone? Follow your paper, your module. Last question, question 25. Okay, look at this paper. For science 1, have we finished this question, 25?
No.
Not yet. 24 finished or not?
No.
24 also not yet. What about for science 3? I think more or less similar. Never mind. Then I start with question 24. Okay, question 24. 23 done or not? Sorry.
23, we are at where the sub B, the B there.
Or B, A done already lah.
Yeah.
Okay, then I start with 23. Okay. 23 this time, this question. Okay. This one, I think most of the classes have done this diagram, correct not? For science 3 done already or not? Chop this answer copy already the other day? Chop
Haven't.
Okay, then I start 23 lah. Okay. Okay, look at question 23. Diagram shows the arrangement of lenses in telescope. This one change to telescope. Okay, for science 3, please change to telescope. Power of lens AP 0.5D and 5D respectively. Okay. So this is question 23. Okay, the first part is you have to draw this diagram. Okay. Please take out a pencil, a pen, copy this diagram. Okay. There's certain parts you need to change. There's a line here, you need to erase a line. Okay. So please change the diagram to this one. Okay. Do it now. For those who haven't, please do it now in 1 minute's time. Draw the diagram. Okay. So draw these two lines. One go direct to the optical center in a straight line. The other line go through the focal point. Okay. And then reflected horizontally. Okay. And then meet up here. So this is an image. The image is here. So the image is located at the focal point. Then this is the first image, not the final one. So to get the final image from here, you draw another line, go to the optical center of the eyepiece, straight. Another one horizontal, deflect to the F. Okay, then you extend, you get here. The image is very, very far. In fact, you can't find intersecting point here. The intersecting point is too far. So we just stop somewhere here. So we take the images at infinity. So first question is why the ray PQRS2 come parallel and slanting? The reason is the lights are from infinity because this one is telescope. Telescope used to see far object, distant object. So the light must come from infinity. The side must come slanting, parallel like this. Okay. Done everyone. Okay, for science 3. Lutras, are you here? Lutras? Can hear or not? I saw you just came in. Lutras, can hear me? Yes, okay, good. Yeah, here now. Richmond? Richmond, can hear me?
Yes.
Can now? Okay. So finish the diagram, hurry up. Okay, the next one
Can.
Can. Okay, good. Okay, calculation now. Find the focal length of A and B. Okay. A should be the smaller power one, 0.5 diopter. This one, focal length is longer, so it should be low power, 0.5 T. When you use this formula to calculate, the focal length will be in meter. So you change to cm, you get 200 cm. I mean, for this length, focal length is 200 cm. Okay. Whereas for P, lens P, higher power, focal length shorter, higher power, which is 5T. So you get the answer in meter, change to cm is 20 cm, okay? And finally, the last part, the calculation, to calculate the distance between the lenses. Okay, distance between the two lenses. So use this formula. FO plus FE because FO, FE basically are at the same point, mean no gap. So the distance between the objective lens and the eyepiece is exactly the distance FO plus FE. So FO, you get the answer 200. FE, you get the answer 20. So it's 220 cm lah, total. Then the distance between lens, objective, and the eyepiece. So you get 220 cm. Understand this? Chan Eng Sing, understand?
Understand.
Understand? For those who just came in, please send your attendance. So you type, you send present to the chat box. Okay, please send present. Type present and send. Okay, Richmond, Lutrus. Okay, the last part of the question, what is a linear magnification? To find linear magnification, you take this formula. For this one, is only for telescope. FO divide FE. FO 200, FE is 20, so you get 10 lah. So meaning that this telescope is not so good lah because the magnification is only 10, meaning that only 10 times bigger. Not so good lah, okay? So got all the answer already? You Jia Jia, got all the answer?
Yes.
Got Vera, got the answer or not?
Yes.
Okay, all right. Everyone got now, so we move on already. Okay, so I see a few of you still sending your attendance. Okay, so remember, those who just came in, you haven't sent your attendance one, please type present and then send. Okay, all right. Next question. State the characteristics. The last one is inverted, virtual, magnify at infinity sign. You know, like you see the diagram, you know already like the answer. The image is inverted, virtual, magnify, and is at infinity. And then G, section G. How can we modify the telescope to increase the linear magnification and the brightness? You remember or not, class? How to make the magnification larger and then it brighter? In the class, I already explained. Okay, now I explain one more time. You listen. Okay, you want to make the final image bigger, larger, right? You must make this FO longer or FE become shorter because magnification is you take FO divided by FE, right? You want the bigger answer, FO must become longer, whereas FE must become smaller. Understand? When you divide, you get a bigger answer, isn't it? Wait, understand? Vera, do you understand?
Yes. Understand.
Okay. So first answer you write there, increase the focal length of objective lens. Okay, first answer. Increase focal length of objective lens. Make this FO longer. When it is longer, bigger answer divide by this one, you get bigger answer. Okay, first answer you can write increase the focal length of objective lens. That's the first one. You can also write another answer, decrease the focal length of eyepiece. Decrease the focal length FE of the eyepiece. Make this one longer, make this one shorter. Understand? Yeah. Okay, now I have a question to ask. Michelle, are you there? Michelle Chua?
Yes, sir.
Michelle, how to make FO longer? How to make FO longer, Michelle?
Make FE shorter.
No, I'm asking you, how to make the FO become longer? Can or not, Michelle? How to make
Okay.
FO longer? Okay, Hao Han Chi, are you there? Hao Han Chi? How he doesn't want to, yeah, how? Can you answer my question now? How to make FO longer? How? You can type, if you want to talk, you can type. How to make the FO longer? How? Okay, let's see what he wrote now. He said, increase the diameter of objective lens. This is an answer. Now, this answer is correct, but later on only now. Okay, come. Actually, now listen. Very simple. To make this one longer means you reduce the power of the lens. When this power lens lower, right? Lower power, the focal length become longer. Right? Not. So you want to make it longer, so you use a smaller power objective lens. And at the same time, when you want to make FE shorter, you use eyepiece with higher power. Higher power, FE becomes shorter. Lower power, FO become longer. Understand now? Michelle, understand? Michelle, understand or not? Chua, Michelle?
Understand.
Understand now? Okay, I'll repeat again now. Use objective lens, higher power. Higher power, use objective lens, lower power. When power lower, focal length, FO become longer. Okay? Whereas the eyepiece use a higher power lens, so the FE becomes shorter. Okay, so that was the first suggestion. Okay, the second suggestion is to make the final image brighter. Brighter, okay, the answer given by Hao Pan-Ji just now. Use a bigger diameter objective lens. When this lens is taller, bigger, right? It can absorb more light to come in. So the final image will be brighter. Okay, so the second answer is increase the diameter of objective lens. Okay, this lens now taller. Taller means can have more light to come in. Okay, so two suggestions now. What answer? Okay, Vera, you get all the answer or not, Vera?
Yes.
Vera, can you read out all your answer, please? Slowly, you read out one by one, slowly.
Increase the focal length of objective lens. Then decrease the focal length of eyepiece.
Yes, good.
Increase the diameter of objective lens.
Repeat the last answer.
Increase the diameter of the objective lens.
Yes, correct. So all the answer are there already, Okay. Got it, Okay, now we go to question 24. Okay, question 24. Student wishes to construct a telescope, okay, using a few lenses. This was an SPM question. Class, you listen probably, you know. Beside the lens power 5D, this one convex lens 5D. So the student provided another two more lenses. I mean, these students are given three lenses, 5D, 2D, 10D. So three lenses, right? You have to choose the best two to make a best telescope. Okay, best telescope. You all must know, you know, telescope are how to choose the lens one. Okay, out of these three, power different one, 5D. This one medium power, this one low power, 2D. 10D is high power. So out of these three lenses, you need to choose two. Okay, first you do like this. I can copy this answer now. The possible combination because for telescope, it should be one low power, one high power. You see, sorry, okay. You go back to telescope, okay, come, let's go back to telescope, okay, a little while, okay. Follow me now, okay, you see telescope. This one is telescope, right? You look at telescope here. Okay, for telescope, right, this one, long wavelength, long focal length. So this one low power. Objective lens is low power because focal length is long. The eyepiece, right? The focal length is very short, so it means this is high power. So you must choose one low power for objective. Another one must be high power for eyepiece. Understand? So you have to choose like that, you know. These are low power, long focal length. These are high power, short focal length. Okay, remember that point. I now go back. So the combination now you can choose. The possible combination is like this law. Okay, you see the suggestion given. Okay. It's already there. Okay, you can see. So meaning that you choose low power, high power, 2 and 5. Low power, high power, 2 and 10. And the other one combination is low power 5, high power 10. So meaning that we have 3 combination, 3 possible combination now. 2, 5, 1 low, 1 high, 2, 10, 1 low, 1 high, 5, 10, 1 low and 1 high. Correct not? Okay. And we need to calculate the focal length of each, you know. For this one, focal length, calculate. Okay, focal length using this formula, 1 over P. Okay, for this one, 2D, power is 2. You get in meter, change to cm is 50 cm. That means this one 50 cm. This one you use the same formula, you get 20 cm. This one 50 cm focal length. This one only 10 cm. This one 20 cm. This one high power, you get 10 cm. Okay, use this formula to calculate. Okay, copy this one. Okay, now why we need to calculate the focal length? For what? Why I ask you to calculate the focal length? Focal length for the low power objective length, focal length of the eyepiece, the high power lens. Why we calculate the focal length? Because we want to know the magnification. To calculate the magnification, you need to take FO divided by FE. Correct not? That's the right reason why you calculate FO, FE. Understand? Okay, next part, you calculate the magnification. You see which one bigger. Now you see. For the first one, 50 divided by 20, so only 2.5. The second one, 50 divided by 10, so we get 5. The best lah. This is the best law. Okay. The last one, 20 divided by 10, FO divided by FE, you get 2. So the best telescope should be this one with the highest linear magnification. 5. Okay. So the answer is this lah. This one is the second combination lah. 2D and 10D is the best. This combination make the best telescope you can do. Okay. Yeah. Okay. So the best is 2D and 10D. And the reason is what? The best combination is 2D and 10D, right? So then what is the reason? What is the reason we choose 2D, 10D? Amanda Lee, what is the reason of choosing 2D, 10D?
Because it has the largest magnification.
Yes, correct. Very good answer. Okay. It has the largest magnification. Okay, that's why we choose 2D, 10D. Thank you, Amanda. Okay, come, we move to the last question. Jayani, are you here? Jayani? Also cannot talk, you type. Okay, let me see what you type. Yes, okay, good. Jayani? Okay, come, we look at the last question. This is slide projector. Okay, the last one. Okay, slide projector is the one projector used in the school. Okay, So you have a bulb, the bulb is here. This is a concave mirror. The mirror is to reflect the light, to make the light from the bulb brighter, okay? You need the light to be brighter, very, very bright. So to increase the brightness, right, you put a mirror here to reflect the light, to increase the brightness of the light. Okay, to make this light travel horizontally, right, or to make the light reflect, follow the same path. So this bulb must place at the focal point. When the bulb is at the focal point of the mirror, so the light will reflect, go, come back according to the same path, go, come back, okay? So cannot simply put the bulb, no, must be at the focal point, okay? And the condenser lens function is to produce the light parallel, okay? The light go parallel, uniform brightness. And this is the object, the slide, okay? And this lens, convex lens, is to refract the light, then to form the image here, the final image is here. The final image must be real because able to capture on the screen, it must be real, and then inverted, and then must be magnified. Okay, in order to get real magnified inverted image, this slide projector must place at a distance between 1f, 2f. To get this answer, inverted, magnified, real, it must be placed between 1f, 2f. Understand? So the slide, the object, must place at a distance between 1f, 2f of this lens. Okay. First answer. Function of concave lens, this one. Concave lens, concave mirror, to reflect the light to increase the brightness. That's the answer. The condenser lens, the answer is to produce parallel light. Okay. To produce parallel light with uniform brightness. That's a function. To produce parallel light with uniform brightness. That's a function of the condenser lens. Okay. Got an answer? Very good attendance. Almost everyone here. Okay. Heng Sing Yu. Get all the answer already? Heng Sing Yu.
Yes, sir.
Okay, very good. Heng. Okay, come. We move to the next section. The last one cancel. Okay. Two normal adjustment. Okay. First, I told you just now, the object distance U must be between 1f, 2f. Okay. Why? Because we want the final image to be magnified, real, and inverted. Okay. So it must be between 1f, 2f lah. Another one is a slide must place inverted. I didn't explain to you just now. Why the slide must be placed inverted? Why then? Can anyone tell me why the slide must place inverted? Nicole Chua, can you come up please? Nicole, can you explain why the slide must be placed inverted?
So to produce an inverted image, to produce an upright image.
Yes, correct. The final image is because this one is for the whole class, for the student to see the slide projector, right? So this image must be stand upright, then only student can see, can understand. But the characteristics of this lens is will be produced inverted image one, That's why you want the final one to be upright. So the object here, the slide must be terbalik, inverted. Okay. When you put here inverted, it inverted again, so it become upright. Understand? But we still say the final image is inverted, Memang is inverted. If you don't put this slide in terbalik, this thing will terbalik one. Understand? So just because we want the student to see the thing clearer, understand, make it upright, so we put this one inverted. Yeah. Okay, one last one is the bulb placed at the focal point. Okay, the bulb must place at the focal point. You know the reason, right? Why the bulb must place at the focal point? Why the bulb must place at the focal point? Okay, the reason is here. Okay, maybe just now you didn't listen properly. We want the light hit the mirror, reflect according to the same line. Okay, go here, come back, follow same line. To get that now, this one must be at the focal point. Hit the mirror, reflect, follow the same line. When you follow the same line, then only can increase the brightness, correct not? That's why we want the light to reflect according to the same pathway. Okay, yeah, that's the reason. Okay, then last, this one I think you just copy, you know already now. Real, magnify, method, and section D, cancel it. Okay, no need do. Okay, finish. Everybody finish. Let me see some of you here. Kathleen Yao, are you here? Kathleen? Can follow the lesson or not? Kathleen Yao.
Yes, sir.
Can Aiman, okay or not? Aiman can follow. Aiman. Can. Okay, Aiman cannot talk, so he types. So see what he typed. He said can, yes. Okay, good. Aiman, remember now, send me the report now after finish class. I sent message to you this morning, right? And Mei Chen, okay, can understand? And Mei Chen, no sound from you. Are you there or Tan Mei Chen? All type we need to want to talk very shy. Yes, okay, thank you. And Nicholas, where is Nicholas? Nicholas here or not? Where are you, Nicholas? Here, Nicholas. Can follow, Nicholas.
Yes.
Can. Nicholas. Pang. 453. Pang, where are you? Pang, are you here? Not here, Pang. Okay, never mind. Okay, come. We move on to your last lesson. Okay, can you take out your last lesson paper? Lesson 6 now. Yeah. Yeah, look at your paper. Okay, come. Actually, you are supposed to have your final exam one. Okay, next week, but it ended up CMCO. So the exam, listen, the exam is put on hold. Actually, we don't cancel the exam because we need to find a way to stream the class. For example, like for science 1, for science 2, some good one may come up science 2, science 1. For science 1, not hardworking one, you go down to science 2 or science 3. And same thing to this 4A1, 4A1, 4A2. Okay, so the exam will still be on. Okay, so most probably is when you come back school, understand? We never cancel the exam. The exam still on. And the Jabatan say so. Jabatan say the exam ditangguhkan, not dibatalkan. That means still on. That means everybody have to study as usual. Okay. This CMCO is not holiday actually. It's not holiday. It's homeschooling day. You study at home. Okay. Yeah. Okay, come. Your last lesson will be image formation by mirror. In a previous lesson class, you have studied convex lens, concave lens. All are lenses, Lens only, you study the lens, concave, convex. Now your last lesson will go back to mirror. So you study mirror. Mirror and lens are different, okay? Mirror, you know what's mirror, right? Lens is like the spectacle, this one is lens, okay? Then we are looking at the mirror now, okay? Come, let's look at a few terminology. I want you to learn now. You look at the diagram, okay? Go on now. The name you must know, la class, okay? Let's say this is a mirror, okay? When the light hit the mirror, the light get reflect, correct? Not this is reflection. So this line is called the normal line. Okay, the sign NO normal. So please jot here. Normal line is NO. This 90-degree line is normal line. Whereas the incident ray is AO. This one no AO incident ray. Okay, jot down. Refracted ray is OB. This one is refracted ray OB. This one incident. This one reflected. Angle of incident is this angle I law. I is angle incident. R angle reflection. Okay. So you must make notes. Both angle incident and reflections must take from the normal line. You see, you must take from the normal line one. Must next to the normal line. You cannot take the angle here or here. Must take from the normal line. Understand? Yeah. So normal incident ray, reflected ray, angle incident, angle reflection, you all know already, huh? Okay, right? Okay, next one, law of reflection. This one just go through very fast. There are two law of reflection. Okay, the first one very simple. Angle incident equal to the angle reflection. The angle I, as you can see in the diagram, IR must be the same, correct? Not? This one no problem. You just need to remember it. Law of reflection. Okay, the second law, incident ray, the normal and the reflected ray lie on the same plane. Same plane means same surface. Same surface. It means here, these three lines, incident, normal, reflected ray, all on the same surface. Same plane means same surface. They are on the same surface. Okay? Understand? Nicholas, understand?
Understand.
Thank you. Okay, who is this Bala Krishnan? Who is Bala Krishnan here? As far as I know, I don't have student Bala Krishnan one. Who is Bala Krishnan?
Sir, it's me, Yuktesh, sir. I using my dad's account.
Oh, yeah, you teach.
Yeah.
Can you send your attendance or not?
Where to send, sir?
Chat, you send in the chat box, send present. You just type.
Okay, sir.
Because the name I cannot recognize, so you please type your own name. You test present. You type you test present. Okay. All right. Now, okay. Thank you. You send already. The next one is constructions. Okay, come. Look at this diagram. Okay. I explain to you step by step. Then only you draw. Okay. First, this is a mirror. Object is here. Common sense tell you that object is here. The mirror must be behind the image must be behind the mirror. But how to construct the diagram to show the image is behind? Okay, you do like this. Okay, first, you know this distance x and this distance y must be the same one. Object, image, the distance from the mirror must be the same. Okay, so you fix a point already. This point, the object, and then the image must be here. And then you draw this line. Go to your eyes. This line, go to your eyes. So here, dot, 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 dot. Here, dot, 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 dot. Here, straight line. Understand? Then you put your eyes here. Then finally, only you add this line and this line to show these two angles same. Because the light hit the mirror must get reflected, correct not? Same thing go to this one, hit the mirror, get reflected. Angle IR. IR must be the same. Okay, then the image is here. You can copy the diagram now. Okay, everyone copy it first. Copy the diagram, huh? Okay, finish, huh? So remember, the mirror produces an image through reflection, you see now. From here, the light hit the mirror, get reflected. So this draw a normal line. Angle incident, reflection must be the same. Another line you draw, get reflected into the eye. Same thing, draw a normal line. Angle incident, reflection must be the same. When your eye see in straight line, that's why you extend it behind the mirror. Behind the mirror, we have to draw with dotted line because there's no light here, no light one. All these are imagination only. That's why the final image is virtual, it's fake one because no light. Basically, no light can pass through the mirror one. There's no light here. That's why it's virtual. Okay. Yeah. Now we see the characteristics of this image. There are 5 characteristics. Okay, please highlight. You have to memorize it one by one. These are the 5 characteristics of the image. Size of image, object same. You see that same size. Okay. The distance, image, object same. Object distance, image distance from the mirror must be the same. Third is virtual. Virtual means behind the mirror. Okay, virtual. Cannot be captured on the screen, is virtual. And laterally inverted is left-right interchange. Laterally inverted, I think you should know when you look at your mirror, look at your own image, right? You see your left hand go to the right hand. Your right hand in the mirror will go to the left hand. Not. The one is called laterally inverted, okay? And the last one is upright, okay? This one okay lah. Okay, 1 minute, memorize this one. Memorize the image, the characteristics of image formed by mirror. Come on, 1 minute later, I'll call you, you answer. Okay, 1 minute, very fast, finish already. Okay, come, let's see. Who Teo Yo Hee, are you there? Teo Yo Hee?
Yes.
Teo Yo Hee, can you answer or not?
Yes.
What are the characteristics of image formed by mirror? Come on, Teo Yo Hee.
Upright inverted.
Upright. Second one, laterally inverted. Third one, virtual. And fourth,
the size of the
same size lah. Object image same size. And the last one,
same distance.
Same distance. The object image same distance from the mirror. Okay, thank you, Teo. Okay, so we have done this. Okay, now can you answer question 1? Everybody answer question number 1. Okay, answer question number 1. I give you the diagram now. You can see the diagram to answer. Okay, follow the diagram to answer. What is the distance between the boy and his image? Initially, the mirror is here. The boy 5 meters away. After that, the mirror moves backward 2 meters. So now become 7 meters already, right? So the boy 7 meters in front of the mirror, his image also 7 meters behind the mirror. So the distance become, you know the answer already, right? So what is the answer? Lim Yan Ming, are you there? Lim Yan Ming, are you around? Lim Yan Ming?
Yes.
Lima, what is the answer lah?
7.
Huh?
7.
No. What is the distance between the boy and his image? You know, you see the question? It's between the boy and his own image. What is the distance? You see the diagram?
14.
Yes?
14.
14. Yes, correct. 7 meter plus 7 meters. So it's 14. Okay, 14 meters. Okay. Okay, now move to example 2. Everybody answer example 2. Diagram show two plane mirrors set angle 100 degrees to each other. A ray strike one of the mirror at the angle 45. Redraw and complete. Okay, I tell you what. On your diagrams, right, the angle 45 doesn't look like 45, you know. Okay, can you erase the line? I want you to change the line. Okay, come, you do like this. Change the line, this one, erase, draw again, so that this angle look like 45 degrees. Okay, can you change the line? Use a correction tape, cover the line, change the line, okay, so that here become 45. Look like 45. Do it now, okay, everyone, change the line. Use a correction tape to cover the line first, then draw again the line. Make the line look like the angle 45, understand? Okay, then you complete the diagram like this. Okay, now. So the light come in, reflect by the mirror, go here. Okay, here 45 degree, angle incident, angle reflection also must be 45. And here draw a normal line. So this angle is 55, you know yourself, like you see here. Calculate, you get this one 35, so here 55. So finally, this angle reflection R is 55, okay, 55 degree, okay. Yeah, finish, everyone? I noticed there's some students still coming in now. Okay, for those who just came in, you haven't sent your attendance one. Please type present and send through the chat box. Okay, through the chat, you type present, then you send. Okay, send to everyone. Don't send to private. Understand? Send to everyone. Okay, come. Let's move on now. Mirror. Curved mirror, this is one you are going to study in your syllabus. Okay, before this class, you listen, don't need to copy anything first, just listen, okay, listen. Before this, you look at this little diagram here, this one is lens. When you see this one, you say this is concave lens, correct not? Concave lens. Now, When a mirror, this is a mirror, you know. So the name also concave mirror, no same shape like that. Okay, the surface of the mirror is here. So it's concave mirror. Concave lens, concave mirror. Okay. Whereas this one you learned before, convex lens. This one is convex lens. Now same shape like this. Surface is outside here now. So this is convex mirror. Remember the name first, you know. The surface, this one is in front here. This one, the surface is here. Okay. So the name, remember, concave mirror, concave lens. This one is convex mirror, convex lens. Understand? But now you see now, the way the mirror reflect the light differently. You see now, in concave lens is diverging the light. Right now you see diverge. This one you learn already, right? But in mirror now, concave mirror is not diverging the light. It's focus the light. You see the light hit, focus here. Hit here, focus the light. So it's the ballet. You see or not? In lens, concave lens is diverging the light. But in the concave mirror, it focus the light, or we say converge the light. Okay, it focus the light into a focal point. This is a focal point. All the light when hit the mirror, it will focus at the same point. Okay, so this is concave mirror. So remember, concave mirror focus all the light to the focal point. Okay, then you look at convex mirror now. Convex mirror is, if we say this lens, right, convex mirror focus the light, but here it doesn't focus, it diverges the light. You see the light hit the mirror reflect the light from the focal point. The focal point is behind. So to draw this line, now you must do like this, you know, hit the mirror, then draw this one, then only draw this one. So the light hit the mirror, reflect, you see like from this point, the focal point is behind. Okay, remember now, light hit the mirror, reflect. You see like reflect from the focal point. The focal point is behind. All these are virtual, no light one. All these are dotted line. So remember that concave mirror focus light, convex mirror diverge the light. This one is diverge light. It's the ballet, you know. Lens are concave lens diverge light, but concave mirror focus the light. Whereas for convex lens focus the light, but for convex mirror, it diverges the light. Clear or not? Please make notes, make yourself clear. Understand? Don't confuse. My experience told me a lot of students confuse one. Between the lens and the mirror, lens, mirror, they cannot make it clear. Okay? I'm very clear already mentioned to you, so please jot down. Okay? Nicholas, okay? Can you understand? Nicholas?
Can.
Ho Wan Yin, where are you? Ho Wan Yin?
Yes, sir.
Can I understand Ho Wan Yin?
Yes, sir.
Can I? Okay, all right. Now we see the name one by one. Okay, for concave mirror, right? This is a focal point. Focal point, all the light focus there. Okay, you can highlight here. Highlight the focal point. It's the bottom here. Highlight. Focal point. Where is focal point? No. Wait here. It's here. Sorry. A little bit confused. Okay, so now focal point. Focus point of the mirror. The focal point F. Okay. Highlight this one. F is focal point. Okay, then P is a pole. Okay, this one is a pole of the mirror. Okay, pole. This one is a pole. Okay, highlight here. Pole of the mirror is P. Okay, pole. Point P is the pole. And C is center curvature. Please highlight. And then I want to ask you, what is center of curvature? Come, listen. Center of curvature is C. Is here now. You see, Come, I use this diagram to explain you. assume this concave mirror is a big circle like this, right? And then the center of this circle is at C here. This is a circle, is the center of the circle. Okay, not the focal point. No, many people say the focal point is the center. No, the center of the circle of the mirror, right, is at C, center of curvature. That's why we say center of curvature. Okay, it's the center of the circle make up the mirror. Okay, center here, center of curvature. I remember that. Same thing goes to this one. If you construct this one to make it a circle, right? This is the center. Okay, center of curvature. And one thing very important, okay, come, you look at here. From the pole to the focal point, this distance is called focal length, small f, focal length. Okay, focal length. See focal length, please highlight focal length, okay? And another focal length, okay, one focal length, two focal length. Two focal length is exactly at C. That means the position of point C is also equal to 2F. 2F, the distance, one F is a focal point, another F, it becomes the center of curvature. Understand? That's why when this is a big circle, this one becomes the radius of the circle, correct not? This one center, so radius is CP lah. Radius becomes CP and also equal to 2F. That's why you get this. Radius equal to 2F. Okay, the radius R equal to 2F. You get this formula, okay? And the radius of curvature R is equal to CP, okay? From C to P actually is a radius R, radius of curvature. Then, can I understand what is name? Focal length, radius of curvature, so make it understand, okay? All these are focal point. Principal axis is the center line, PFC. Principal axis is the center line. This one, center line, PFC. PFC is a principal axis. Okay? Can so far can everybody? You test, can follow or not? You test.
Can, sir, can.
Can Okay. And Tê Yi Hang, can hear or not? Tê Yi Hang, can understand?
Yes, sir, can.
Can okay. Okay, come, we move on. All this point you know already, Okay, now relationship between the curvature and the F. Okay. Slowly, okay, it's here. I'm using the mouse a bit difficult. Okay. Relationship between the curvature of the mirror and the focal length. You look at here. This mirror, less curve. So jot down here, less curve. When you see the mirror less curve, right? You see the focal length is longer. You see or not? When this mirror is curved more curve, then the focal length becomes shorter. So please make notes. The more curved the mirror, the shorter the focal length. The shorter its focal point. Focal length shorter lah. Less curve, long focal length. Curve more, focal length become very short. Okay, make sure now you know this. Okay, now I think we have only enough time just to draw one diagram. Never mind, you learn first. Learn one diagram also, never mind. Okay, as I want to start with a concave mirror. Can you jot down here? It's the same like image, For mirror also, for formation of image, you need to draw the diagram to find where's the image, what are the characteristics of the image. So for mirror, you need to learn 3 lines. Okay, first line, look at here. Concave mirror, from the object, draw horizontal line, hit the mirror, it will reflect the light through the focal point. This one is line number 1. Please put here number 1. Line number 1 is a compulsory line, means for all the diagram, you must draw this line to find the answer. Okay, so this one is only for concave mirror, not convex, concave mirror. I want to focus with concave mirror first. The first line, okay, the second line is here. Here, please write here number 2. Concave mirror, look at concave mirror only. The second line is from the object, the light pass through the focal point. It will hit the mirror, then reflected horizontally. This is second line. From object, connect to the focal point. When hit the mirror, reflected horizontally. This line number 2. Understand? All right. Then line number 3 for concave mirror is here. Concave mirror. Just focus on concave mirror first. This one is very special. From the object, when the light passes through the optic center of curvature C, it will hit the mirror, then come back according to the same line. You see, go hit the mirror, come back, same pathway, same line. Understand? This line is very unique. Remember now. The light connecting the object then pass through the center of curvature C. It will go hit the mirror and then come back, follow the same line. This is line number 3. Okay, now listen. You have learned line 1, line 2, line 3, but to find the answer, you want to draw the diagram to find the image of a mirror, right? You need only draw 2. No need draw 3. 2 out of 3 lines you draw. Okay, let me tell you. Normally we draw line 1, line 3. Line 2, you can, don't need to do. Line 2 is a little bit confusing. So, in most of the cases, we draw line 1, line 3, that's all. You can get the answer already, okay? Okay, now can you finish up the first diagram before I stop? Okay, I want you to draw one diagram only, the first diagram. And this one, Okay, come look at this one. This one is a first case, okay? Let's finish up this one. Okay, the first diagram, the object shorter than the focal length. Object distance U smaller than the focal length. You see now? This is a focal point. Focal length is here. Object is here. So the object distance very short compared to the focal length. So for first case, U is here, shorter than the focal length F. Okay? So you draw line number 1. You see? Line number 1, parallel, hit mirror, go to the F. This line number 1. Then you do line number 3. Line number 3 is connecting the object and the C, center of curvature. It will hit the mirror and then come back. You go, come back, follow the same line. Okay? This line number 3. Line number 2, no need. Connecting C and the object, hit mirror, come back, same line. Understand? Then go into your eyes. So eyes is here, C in front. So you must extend behind the mirror to find the intersecting point. So behind here is dot, okay? No light here actually. The light cannot pass through the mirror one. So the final image is here. So this image use dotted line because it's virtual. No light there, so it's virtual image. So please complete the diagram. And this is something very good, you know, you see now. This mirror can make us see something upright and then become bigger. So which is very good. When you look at a mirror now, so your eyes become bigger. So girls will be very happy lah. When they use this mirror to make up, so their eyes become very big. Correct or not? Ho Wan Yin, correct?
Yes, sir.
Correct, So it will make yourself, your object, so become bigger, upright. Virtual or real, the one doesn't matter. As long as you see something bigger, so it's good already. And then it's upright and then bigger, you know, very good. This kind of mirror can make you see something bigger. Okay. All right. So the last one, okay. The characteristics. Yeah. Virtual, magnify, upright. Okay. Virtual, magnify, upright. And the application is, as I say lah, makeup mirror. This one can use as makeup mirror. Bigger is a mirror for people, for the ladies to make up, because it become bigger, right? You can see yourself, your eyes become bigger. Okay. And also same for men, shaving. For shaving, you need a mirror also, right? Shaving mirror also can. For ladies, it's makeup mirror. And for men, is shaving when you shave, okay? Shaving mirror. Okay, I think I stop here. I don't want to drag anymore. Okay, so any question to ask here? No. So I stopped share this picture already now. Okay. Okay, come back here now, everyone. Once again, those who haven't sent your attendance, so please send your attendance. You type present, you send in the chat box. Okay. Right. Okay. I want to say thank you to everyone here. Very good attendance. I think almost everybody here. Okay, which is a good sign. And then please keep up this spirit now, every lesson. So our lesson will last until 18 December. Okay, 18th of December. Okay, so everybody please take good care of yourself. I need to take pictures. Sorry. As evidence. Sorry. Wait now. Can you on your camera? Everybody on camera. Can or not? On your camera, please. I need to take a little bit pictures as evidence. The class is carry on. Then can on your camera just for a short time only. Can or not? I need to take pictures. I want to see your face. Zhong Jiayin, where are you? Zhong Jiayin, never see your face. Zhong Jiayin. Nicole Chua, never see your face. I see Regime Lim there already. Nicole, hi, how are you? Amanda, where are you? There, I see your face. Yeah, okay, come, let me take the picture first. Okay lah, all right, thank you everybody. Okay, take good care of yourself. Okay, stay home, stay safe. Okay, bye-bye. Bye-bye, everyone.
Thank you, sir.
Thank you,
Thank you,
sir.
Yeah,
sir.
okay, bye-bye, bye-bye.
Thank you, sir.
Thank you, sir.
Yeah, bye-bye.
Thank you, sir.
Yeah,
Thank you,
bye-bye.
sir.
Thank you, sir.
Okay, bye-bye. Yeah, bye-bye.